Here's the truth. Not all numbers are equal. Some numbers are just names. Some show rank, some measure distance, and some, they measure distance with a true zero. If you don't understand this difference, your analysis in R can collapse before it even begins. Today we're going to uncover what numbers really mean, the levels of measurement, and why this simple idea is the foundation of data science. Before we even write code in R, we need to understand the logic of data, because in R, a number is never just a number. It carries meaning. And the way you store that meaning, as a factor, an ordered factor, or a numeric, decides whether R will give you useful results or nonsense. Think of it like driving a car. If you put petrol in a diesel engine, the engine won't complain at first, but soon the car breaks down. Same thing with data types in R. Now here's the key idea. Levels of measurement are like a ladder. Each level includes the qualities of the one below it, but adds something new. Nominal, the base. Ordinal, adds order. Interval, adds equal spacing. Ratio, adds true zero. It's like climbing from private to general in the military. Each rank has all the powers of the ones below, but with new authority. That's how numbers work too. Let's start at the bottom. Nominal data. Nominal comes from name. It's the simplest form of data. Jersey numbers on a football team. Blood types, yes or no. The number or label doesn't mean quantity. It just identifies a group. Jersey number 10 isn't twice as skilled as number 5. It's just an ID tag. In the military ladder, this is like recruits all wearing uniforms. The uniform says who belongs, but it doesn't tell you anything about rank. In R, we store this as a factor, or sometimes a logical, true, false. Nominal data is all about categories. Climb one step higher. Ordinal data. Here we add something new. Order. Think of military ranks. Private, sergeant, captain, general. There's a clear chain of command. Higher outranks lower. Or medals in the Olympics. Gold, silver, bronze. There is ranking. But the difference between gold and silver isn't the same as the difference between silver and bronze. Another example, clothing sizes. Small, medium, large. There's order but not equal spacing. So ordinal data has the quality of nominal, naming categories, plus the new quality of order. In R, this is a factor with levels, an ordered factor. It tells R, yes here, but don't treat it like math. Climb another step. Interval data. Here we add another quality. Equal spacing. Think of temperature in Celsius or Fahrenheit. The difference between 10° and 20° is the same as between 20° and 30°. The spacing is equal. But here's the catch. 0 is not absolute. 0 degrees C doesn't mean no temperature. It just means the point where water freezes. So interval data inherits the qualities of nominal, categories, ordinal, order, and adds equal spacing. But it's missing one thing, a true zero. In R, this is usually stored as numeric, double, but you must interpret it carefully because you can't say 20 degrees Celsius is twice as hot as 10 degrees Celsius. That's nonsense. Finally, the top of the ladder, ratio data. This is the strongest level. It has all the qualities of interval, ordinal, and nominal, and adds the most powerful quality, a true zero. Think age, weight, height, income. 0 means nothing. $0, just no money. 0 weight, just no mass. And because of that, you can make statements like $200 is twice as much as 100. 20 kilos is 4 times as heavy as 5 kilo. Ratio is the general in the military ladder. It holds every power the lower ranks have, plus the authority of true zero. In R, this is also stored as numeric, but with full mathematical meaning. So let's climb back down the ladder. Nominal, categories only. Ordinal, categories plus order. Interval, categories plus order, plus equal spacing. Ratio, categories plus order, plus equal spacing, plus true zero. Each level contains the one below it, but adds a new superpower. Now, why does this matter in R? Because when you define your data, R doesn't just store values, it interprets them. If you mark a variable as a factor, R will treat it as categories. If you make it an ordered factor, R knows there's a hierarchy but no math. If you leave it as numeric, R assumes equal spacing and maybe true zero. Here's a quick example in R. Gender, factor C, male, female. Nominal rank, factor C, private, sergeant, captain, ordered, to true. Nominal ordinal temperature, C, Joe, 10, 20, 30. Terran interval income, C, 0, 500, and $1,000. Terran ratio. So remember this, a number is never just a number. Its meaning is shaped by the level of measurement. Understand that, and you won't just learn R. You'll learn to think like a data scientist, seeing beyond numbers into the logic that makes them powerful.